Chapter 1. From Red Dust to Green Planet, the Mars Dream. Humanity has always stared at the sky with wonder. For thousands of years, our ancestors looked at the stars and wondered what lay beyond the darkness. They imagined gods, spirits, and distant heavens. But one point of light has always stood apart, glowing with a strange reddish fire. Mars, the red planet. For most of human history, Mars was a mystery, a wandering star, a symbol of war, a silent neighbor in the night sky. But today, it represents something far more powerful. It represents hope. It represents survival. It represents the possibility that humanity does not have to die with Earth. Imagine standing at the edge of a vast Martian canyon. The wind whispers across red dust. The horizon stretches into an endless alien desert. Above you, Earth hangs in the black sky, a fragile, glowing blue dot. This is not science fiction. This is our future, waiting to be built. By the 22nd century, Earth may no longer be enough. Our population is rising, resources are shrinking, climate systems are under stress. The very planet that gave us life is beginning to show its limits. Mars offers an answer, not as an escape but as an expansion, a second home for humanity, a backup for civilization, a new branch of human destiny growing alongside our birthplace. But turning Mars into a livable world is not a small ambition. It is the greatest challenge our species has ever faced. To terraform Mars means to awaken a dead world and teach it how to live. Before it becomes a paradise, we must understand what Mars truly is, what it used to be, and what it lost. Billions of years ago, Mars may have looked very different. There is evidence of ancient rivers carved into its surface, dry lake beds, vast canyon systems shaped by flowing water, minerals that only form in the presence of long-standing liquid water. Mars may once have been alive, not with trees or animals, but with motion, chemistry, warmth, and possibility. But something went wrong. Mars lost its magnetic field, and without that invisible shield, the solar wind slowly stripped away its atmosphere. The oceans evaporated. The sky thinned. The temperature collapsed. The planet died, slowly, silently, leaving behind a frozen desert of dust and stone. And yet, not everything was lost. Under the polar ice caps, water remains locked away. Deep beneath the surface, frozen reservoirs of ancient oceans still exist. Mars is not a completely dead world. It is a sleeping world, and humanity dreams of waking it up. Terraforming Mars begins with a question so large it feels impossible. How do you make an entire planet warm again? The answer begins in space. Far above Mars, scientists imagine giant orbital mirrors, structures so massive they could reflect sunlight toward the poles. These mirrors would act like artificial suns, melting frozen carbon dioxide and water trapped in the ice. As the ice melts, gas is released. As gas is released, the atmosphere grows thicker. As the atmosphere thickens, the planet begins to warm. A slow chain reaction, changing a world. Some proposals go even further. Massive factories on the Martian surface could manufacture greenhouse gases, pumping warmth into the atmosphere over centuries. Others imagine controlled asteroid impacts, steering frozen bodies rich in ammonia toward Mars, delivering heat and atmospheric material in colossal bursts of energy. This is not gentle science. This is planetary engineering, raw, dangerous, unprecedented. This is humanity learning to play the role of a god. But we are not there yet. Mars is still cold, still dry, still hostile, and we're only at the beginning of this story. Before Mars can host cities, before it can grow forests, before footsteps can echo across its open surface without a spacesuit, it must first be understood. Mars is not just a planet. It is a frozen record of time. Every crater is a scar from cosmic violence. Every canyon is a memory of flowing water that no longer exists. Every grain of red dust once touched winds that blew across a wetter, warmer world. When we talk about terraforming Mars, we are not just talking about construction. We're talking about resurrection. But resurrection comes at a cost. The planet we see today is brutally indifferent to life. The gravity is weak. The air is thin. The cold is absolute. And the radiation that crashes down from space strikes the surface without mercy. On Earth, our magnetic field guards us like an invisible shield. It bends solar radiation away, preserving our atmosphere and protecting all living things. Mars has no such guardian. Imagine standing on its surface without a suit. Not only would the cold and lack of oxygen kill you within seconds, but invisible storms of radiation would begin to tear through your cells. This isn't just a difficult world. This is a world actively hostile to the very concept of life. And yet, humanity sees opportunity where nature sees silence. The dream of a green Mars did not begin in modern laboratories. It began decades ago, in the imaginations of scientists who dared to think beyond survival and toward expansion. Carl Sagan, Robert Zubrin, visionaries who looked at Mars and didn't see a dead rock. They saw a challenge, a process, a future. They proposed ideas once thought absurd, altering an entire planet's atmosphere, triggering artificial greenhouse effects, restarting a climate system that died billions of years ago. At first the world laughed. Then robots landed on Mars. Then rovers rolled across its surface. Then satellites mapped water beneath its soil. Suddenly, the dream didn't feel so impossible. But terraforming is not one action. It is not pressing a button. It is a sequence of transformations so large, it redefines what technology means. The first phase is called planetary warming. Mars must be heated before anything else can happen. Without warmth, ice cannot melt. Without melting, gas cannot be released. Without gas, there is no atmosphere. Scientists believe Mars already holds enough frozen carbon dioxide to thicken its atmosphere if it could just be released. But nature alone won't do it. So humanity would have to intervene. Orbiting mirrors, larger than cities, could be constructed in space. These mirrors would focus sunlight like a magnifying glass, aiming it directly at the polar caps, slowly at first, then faster. The ice would begin to hiss, to crack, to evaporate. Carbon dioxide, once locked in ancient frost, would rise into the sky, surrounding the planet in a growing blanket of gas. The temperature would rise, degree by degree, year by year, century by century. But warming alone is not enough. Mars needs pressure. Right now, its atmosphere is less than 1% of Earth's. Humans cannot survive in that. Liquid water cannot exist in that. The sky itself is too thin to hold heat, so the atmosphere must become thick, heavy, present. Some proposals involve surface factories that manufacture artificial greenhouse gases, extreme industrial systems powered by nuclear energy or massive solar farms. These gases wouldn't just heat the planet, they would protect it. They would build a sky strong enough to keep warmth locked in. Others propose redirecting asteroids, not to destroy Mars, but to gift it new material. Asteroids rich in ammonia could deliver not only mass, but chemical ingredients that alter the atmosphere itself. A dangerous strategy, a precise strategy. One mistake, and the dream could shatter into catastrophe. But all great transformations come with risk. Slowly, imperceptibly, Mars would change. The horizon would still be red. The sky would still be thin, but it would be no longer dead. It would be becoming, and in that transformation lies humanity's greatest hope. Mars is not just a planet of the future. It is a mirror of what Earth could become, and what humanity could lose, if we remain confined to a single world. But as the surface warms, as ice begins to melt, a deeper question begins to surface. Should we do this at all? As Mars slowly awakens, a darker question begins to rise beneath the hope. Is it right? Is it right for humanity to take a world shaped by billions of years of natural history and reshape it in our own image? Terraforming is not just science. It's philosophy. It is ethics. It is power. and power has always come with consequences. Some scientists believe Mars may still hold microscopic life, ancient bacteria frozen beneath the soil, surviving in hidden salty pockets of underground water. If that life exists, even in the simplest form, then terraforming becomes more than engineering. It becomes a choice about extinction. Do we preserve a silent alien ecosystem we may never fully understand? Or do we prioritize our own survival as a species? This is not a simple debate. There are no simple answers, only consequences that stretch across time. Imagine the first generation of humans born on Mars. They have never felt Earth's oceans, never touched Earth's forests, never walked barefoot through Earth's soil. Mars is all they know. For them, red dust is home, thin skies are normal, artificial suns hovering over sealed habitats are simply life. These are not visitors to Mars, they are Martians. A new branch of humanity, shaped by a different gravity, a different sky, and a different destiny. Terraforming is not just about changing a planet, it is about changing us. The cost of all this is almost incomprehensible. Trillions of dollars, centuries of continuous effort, generations of workers and scientists who will never live to see the final result of their labor. This is not a project for personal glory. This is a gift to the future, a seed planted by people who will never sit in its shade. And that requires a level of global unity we have never achieved. Nations would have to cooperate. Resources would have to be shared. Knowledge would have to be open. Mars would not belong to one country, one corporation, or one flag. It would belong to the species. And with that unity comes vulnerability. What if the technology is misused? What if errors turn Mars into something worse than it is now? What if unchecked ambition leads to disaster? Terraforming is not a guaranteed success story. It is a gamble on a planetary scale. Yet humanity has always taken gambles, crossing oceans, splitting the atom, leaving Earth's atmosphere for the first time. Every great leap forward carried the risk of failure. And without those risks, we would still be cave-strapped creatures staring at the sky without understanding it. Mars offers us something Earth cannot: perspective. When you stand on another world and look back at Earth, distant, fragile, glowing, you understand something. Our home is not infinite. Our time is not guaranteed. A single planet can be lost. And because of that truth, we must learn to spread. Not for conquest, not for power, but for survival, for continuity, for hope. Terraforming Mars is not a race. It is a relay. One generation begins the process, the next advances it. Another finishes a stage they never started. This is humanity thinking not in years, but in millennia. And yet, we are only at the beginning of the dream. We have warmed the planet in theory. We have thickened the air in imagination. We have considered the moral cost. Now comes the most difficult step of all: creating life. To truly awaken Mars, warmth and atmosphere are not enough. A planet must breathe, cycle, and evolve. That means life, not forests, not animals, but something far more ancient and far more powerful: microbes. The first pioneers of any living world. Scientists believe extremophile organisms, tiny life forms that can survive radiation, freezing temperatures, and toxic environments, could be engineered to survive Martian soil. These microbes would be designed to consume carbon dioxide and slowly release oxygen as waste. Not fast, not dramatically, but persistently, quietly, year after year, century after century. Mars would not suddenly turn green. It would slowly begin to shift its chemistry, one invisible breath at a time. As oxygen levels rise, another transformation becomes possible. Water! Beneath Mars, vast frozen reservoirs of ancient water remain locked inside the crust. As the planet warms further, this water could melt and rise. Underground lakes could form. Shallow seas might appear in low-lying basins. Rivers could begin to carve once more across ancient dry channels. Mars would not look like Earth. but it would begin to resemble something alive. But even with air and water, Mars faces its greatest enemy, the sun. Without a magnetic field, solar radiation still strips away the growing atmosphere. The healing process would be undone as quickly as it begins, which is why scientists imagine one of the most ambitious ideas in human history, an artificial magnetosphere, a massive magnetic generator placed in space between Mars and the sun, creating a protective magnetic bubble around the entire planet. A shield the size of a world, a man-made guardian against a star. If successful, Mars would stop bleeding its air into space. The atmosphere would stabilize. Water could remain liquid. Temperatures could hold steady. For the first time in billions of years, Mars would have a sky that stays. Imagine standing there then, the sky no longer thin and black but softly colored by scattering light. The air no longer deadly but dense enough to feel against your skin. The temperature no longer instant death but cold in a way that feels survivable. Still alien, still distant, but no longer impossible. Colonies would begin not as open cities but sealed ecosystems. Domes with forests inside. Artificial rain, carefully controlled oxygen levels. Over time, domes would grow larger, systems more sophisticated, dependence on Earth slowly fading. Mars would begin its longest journey of all, independence. This is still the early dream, still the fragile stage. Mars is warming, breathing, changing, but it is not yet a world for bare human footsteps, not yet a second Earth. It is still in its infancy, and like all infants, it is vulnerable. And this is only the first chapter of the story. Mars is no longer just a frozen rock in the sky. In this vision of the future, it has become something far more fragile and far more precious. A world in transition, a planet in recovery, a child learning how to breathe again after a long sleep that lasted billions of years. The first true Martian settlements would be born in this fragile phase. They would not be cities yet, and they would be lifelines. Pressurized habitats buried beneath the surface to shield inhabitants from radiation, underground tunnels lit by artificial suns, hydroponic farms growing food without soil, water recycled endlessly because every drop would matter more than gold ever did on Earth. These pioneers would not be conquerors. They would be caretakers, engineers, botanists, biologists, children raised under red skies, taught from birth that survival is not guaranteed, and that every breath is earned through machinery, discipline, and hope. Mars would teach humanity something Earth never could: humility. There would be no luxuries in the beginning, no oceans to wander, no forest to lose yourself in, only work, maintenance, community, and an understanding that one cracked seal, one failed system, one neglected protocol could mean the end of everything. And yet, people would choose this life, not because it is easy, but because it matters. Because being part of the birth of a new world is something no previous generation in human history has ever experienced. As Jules Verne imagined journeys to the moon, and as early astronomers mapped the heavens with fragile glass lenses, we now stand as the generation that dares to imagine turning another planet into a home. Mars would not become Earth. It would become something new, something shaped by human will and Martian silence. And with that transformation comes a final realization: terraforming is not about escaping Earth. It is about learning to value it. Only when you leave your home do you truly understand how rare it is, how fragile, how irreplaceable. If Mars can be healed, then perhaps Earth can be protected. If humanity can learn to reshape a dead world with patience and care, then perhaps we can learn to stop damaging the one that gave us life. The dream of Mars is not a rejection of Earth. It is a promise to it. Chapter 2. Mars' Harsh Reality. The starting line. Before Mars can be transformed, it must first be confronted. Not imagined, not romanticized, but understood in its raw, unforgiving truth. This chapter is not about dreams. It is about obstacles, and Mars is nothing if not a world built from them. The average surface temperature on Mars is colder than the coldest places on Earth. Not occasional cold, not seasonal, permanent, biting, planet-wide cold. A world where water freezes instantly and warmth is a memory written into stone. The air is not air as we know it. It is a thin, ghost-like veil made mostly of carbon dioxide. There is almost no oxygen, almost no pressure. A human exposed to it would not suffocate slowly. They would lose consciousness in seconds. Their blood would begin to boil because of the lack of pressure, not from heat, from physics. Mars does not merely lack life-supporting conditions, it actively destroys them. Its gravity is only about a third of Earth's. This weak gravitational grip means it cannot hold onto a thick atmosphere for long. Even if we build one, Mars tries to let it slip away. The planet is constantly leaking itself into space, and above it all, invisible and relentless, is radiation. No global magnetic field protects Mars. Solar winds strike the surface unfiltered. Cosmic rays pass through soil, metal, and flesh with equal indifference. On Earth, this invisible storm is bent away. On Mars there is no shield, no barrier, no mercy. This is the starting line, not a blank slate, a battlefield. Water, the foundation of every earthly ecosystem, exists on Mars only in hiding, frozen at the poles, locked beneath dusty crust, trapped inside minerals. There are places where ancient rivers once flowed, but today they are only scars, dry, silent, eternal. There are no clouds that bring rain, no oceans to balance temperatures, no trees to breathe life into the air, no soil rich with organic decay, only regolith, a toxic fine dust laced with chemicals that are deadly to terrestrial life. Even sunlight is weaker here. Mars sits farther from the sun. The light is dimmer, colder, less generous. Solar panels produce less power. Warmth is harder to capture. Growth is slower, weaker. Every system Earth relies on happens naturally. Every system Mars would require must be built, engineered, maintained, protected. And yet, within this hostility lies strange opportunity. Mars is not as chaotic as Earth. There are no hurricanes, no earthquakes tearing continents apart, no raging oceans. The planet is still, predictable, cold but stable. That stability is one of its greatest strengths. A frozen world is easier to control than a raging one. A quiet world is easier to shape than a violent one. Mars, in its deadness, offers a strange kind of peace. But peace alone cannot sustain human life. To survive here, humanity must rewrite the rules of habitability itself. Terraforming does not begin with hope. It begins with brutal honesty. Mars is not waiting for us. It is not welcoming. It is not designed for us. If we want to live here, we must force the planet to change, and it will resist every step of the way. Mars is not just cold. It is exhausted. It is a planet that burned bright in its youth, then slowly lost the invisible systems that kept it alive. To understand why terraforming is so difficult, we must look deep into the planet's broken heart. Long ago, Mars possessed a magnetic field. A molten, churning core created a planetary shield, just as Earth's does today. This shield protected the atmosphere from the violent winds of the sun. It was Mars' armor, its guardian. But that churning stopped. The planet's core cooled. The dynamo shut down. The magnetic field collapsed. Without it, Mars was left naked in the storm. Solar wind began to rip away the upper layers of the atmosphere, molecule by molecule, century by century. What was once a thick, life-sustaining sky was slowly stripped into space. Pressure fell, heat dissipated, water evaporated, then froze, then vanished beneath the surface. What remained was a husk. Terraforming, therefore, is not just about building something new. It is about repairing a system that fundamentally failed, and that is far more dangerous. The Martian surface is coated in something more hostile than red sand. It is covered in perchlorates, toxic chemicals lethal to most terrestrial life forms. This dust can damage lungs, poison water, and destroy organic material. Anything grown on Mars soil would first require the soil to be cleansed, neutralized, or completely replaced. Even construction itself is harder here. Metal becomes brittle. Machinery degrades faster. Lubricants freeze. Electronics decay under cosmic radiation. A single storm of charged particles from the sun could destroy delicate systems in hours. Mars does not forgive mistakes. Human bodies are not designed for this world. Gravity is so weak that muscles weaken quickly. Bones lose density. Hearts change shape from pumping against less resistance. Eyes deform. Immune systems weaken. A long-term human presence on Mars is not just a technical problem. It is a biological gamble. Artificial gravity habitats may be required, spinning stations that recreate Earth-like gravity through motion. Genetic treatments might become necessary to help future generations survive lower gravity. Medical science would need to evolve alongside the planet itself. In some ways, Mars does not need to change as much as humans do. We are the ones trying to fit into a world not built for us. There's no global weather system as we know it, only dust storms. Some small and brief, others massive and planet-wide, capable of blotting out the sun for weeks. These storms are not violent winds like hurricanes. They are slow, creeping walls of dust that choke machinery, cover solar panels, and infiltrate every crack and seam. A single global dust storm could starve colonies of energy, silence them, freeze them, erase them. This is the environment that humanity proposes to tame. Not a challenge, a trial, a filter. Only the most careful, coordinated, advanced civilization could hope to survive it. And even then, only barely. Mars is not a welcoming frontier. It is a test of whether we deserve to expand at all. Imagine that everything around you is not built from solid matter, but from invisible fields, gently vibrating, endlessly moving, like waves across an infinite ocean. This realization marked one of the greatest revolutions in human understanding, because in the quantum world, particles are not just tiny solid dots. They are expressions of something deeper, something more fundamental. They are ripples in invisible fields. Long before modern physics, humanity believed the world was made of indivisible pieces called atoms. Tiny, solid units of matter, like grains of sand, stacked together to create everything. But as scientists looked closer, the truth became more mysterious and more beautiful. They found that beneath atoms, there were smaller entities, electrons, protons, neutrons. And beneath even those were stranger things still, quarks, leptons, bosons. But behind all of them was something far more elegant. Quantum fields. You can picture a quantum field as an invisible fabric stretched across all of space. A silent, endless surface, like a calm lake before the wind touches it. Each type of particle we know has its own field. There's an electron field, a quark field, a photon field. And when these fields vibrate, what we observe is a particle. A particle is not a thing. It is a motion, a tiny tremble, a delicate wave in a vast, unseen ocean. This means that when you look at your hand, you are not seeing solid matter. You are seeing the music of fields. Every atom in your body, every thought in your mind, every breath you take is a symphony of vibrations, happening in perfect silence. The fields are everywhere. They exist even in what we call empty space, because in quantum physics, there is no true emptiness. Even a perfect vacuum is alive. Fields cannot be turned off. They are always there, always fluctuating, always humming. This is what physicists call zero-point energy. The lowest possible energy a field can have is not zero. It is a restless, gentle motion that never stops. Space itself is not still. Space is alive, and inside that silent activity, quantum echoes ripple endlessly. Imagine space as a calm, dark ocean. Now imagine that even when no wind blows and no boats move, Tiny waves still shimmer across its surface. That is the quantum vacuum. Now let us look deeper at how particles interact through these waves. In everyday life, when two objects touch, we say they collide. But in the quantum world, touching is not required. Particles influence one another through fields. They exchange something called force-carrying particles. For example, electromagnetism, the force that makes magnets attract or repel and allows electricity to flow, is carried by particles called photons. These photons are not just light. They are messengers, tiny packets of energy traveling through a field, whispering instructions from one particle to another. Pull closer, push away, move this way. Gravity, the force that holds planets in orbit and draws you gently toward the Earth, is believed to be carried by hypothetical particles called gravitons. Mars is a world of extremes. Temperatures plummet to hundreds of degrees below freezing at night, while daytime highs rarely reach levels that would make earthly life comfortable. Its air is thin and bitter, mostly carbon dioxide, providing almost no protection or oxygen for humans. Gravity is only a fraction of Earth's, causing long-term challenges for muscle and bone health. There is no magnetic field, leaving the surface exposed to radiation from the sun and cosmic rays. Every step a human would take here is a battle with the environment. Water, essential for all life, is frozen or trapped underground, and the soil is toxic, filled with perchlorates. Dust storms rage across the planet, sometimes spanning continents, covering solar panels and infiltrating machinery, demonstrating that even in apparent calm, Mars is a planet that resists human occupation. Surviving here is not just a matter of engineering habitats, it requires rethinking life itself. Colonists would need sealed, pressurized shelters, hydroponic farms, and water recycling systems. Artificial gravity may become necessary for long-term settlement to prevent bone loss and cardiovascular issues. Even electricity generation is difficult, as the farther distance from the sun weakens solar power output, and dust storms can block sunlight for weeks. Every habit we take for granted on Earth, from breathing to eating to drinking water, must be engineered, maintained, and carefully monitored. One mistake can be fatal. Mars is not a frontier. It is a crucible, testing human ingenuity, resilience, and patience. Yet within this harshness lies opportunity. Mars is stable in ways Earth is not. There are no earthquakes, no hurricanes, no raging oceans. Its surface is predictable, its long seasons consistent, its gravity low but constant. This stillness allows for precise interventions, warming the planet, building an atmosphere, and introducing microbial life. Terraforming will not be instant. It will unfold over centuries, maybe millennia, requiring careful planning, scientific breakthroughs, and generational effort. Mars demands a patience humanity rarely practices, but it also offers the chance to shape a world deliberately, to design habitability from first principles, rather than adapting to the chaos of a pre-existing ecosystem. Every challenge, from thin air to frozen water, from dust storms to radiation, reinforces the magnitude of the task ahead. Colonization is not about planting flags. It is about survival, transformation, and understanding our responsibility to a new world. Mars tests not just our technology, but our ethics. Do we preserve its natural history, or do we bend it entirely to human will? The planet's harsh reality forces humanity to confront its limits, and in doing so, to imagine new possibilities. The first settlers will not inherit a hospitable world. They will inherit a challenge to survive, to adapt, and to slowly coax a dead planet toward life. And in that struggle lies the seed of all future human settlements. Mars will not be tamed quickly. It will demand ingenuity, courage, and vision. But for those willing to endure, the reward is nothing less than a second home for humanity, a place where survival is hard, but hope endures. Mars is a planet defined by absence, an absence of warmth, of protection, of the atmospheric richness that makes Earth a cradle for life. But in that emptiness lies a clarity that few worlds provide. Every obstacle is visible, measurable, and painfully real. The final truth about Mars' harsh reality is that it leaves no room for error. Every human action must be deliberate, calculated, and monitored. The planet does not bend to convenience. It does not forgive complacency. It does not allow shortcuts. This is a world where survival is earned, moment by moment. Radiation exposure remains one of the greatest threats. Without a magnetic field, Mars is bombarded constantly by charged particles that can damage cells, accelerate cancer risks, and destroy electronics. Colonists will live in shielded habitats, underground chambers, carved into the regolith, or structures covered in thick layers of Martian soil. Even movement on the surface will be timed to avoid solar events, meaning that daily life must be coordinated with the moods of a distant star. Simple tasks, repairing a panel, gathering samples, checking equipment, become high-stakes operations. Time outside is limited. Every excursion is a risk. Every second counts. Then there is the atmosphere, thin, fragile, offering only a whisper of pressure. This forces habitats to maintain near-perfect internal stability. A single puncture, even a tiny fracture, can trigger catastrophic depressurization. There are no emergency rooms waiting to save someone. There's only the cold, the vacuum, and silence. For colonists, tools must be reliable, suits flawless, and systems redundant. Mars demands engineering perfection, not excellence but precision so unwavering that humanity has scarcely achieved it at scale. Terraforming begins not with grand planetary machines, but with ensuring that each human breath is safely produced, filtered, and preserved. Food production poses another monumental challenge. Earth's soil is alive, filled with microbes, nutrients, and cycles that sustain plants. Mars' soil is sterile and toxic. Agriculture will rely on hydroponics, aeroponics, and genetically tailored crops. These systems require water, energy, and constant oversight. A single malfunction can threaten an entire food supply. Mars forces humanity to become caretakers of closed ecosystems, relearning the delicate balance that Earth naturally provides. Every leaf that grows is a triumph against planetary hostility. Psychological survival is equally important. Life on Mars is isolation intensified. No forests, no oceans, no rain, no wind carrying the scent of life. Only dust, rock, and red horizons. Days filled with routine maintenance. Nights illuminated by artificial light. Communication with Earth delayed. The sense of distance, of being separated from the cradle of humanity, will weigh on the minds of the first Martians. Their strength will not come from the planet, but from each other. Community will be their lifeline. Cooperation will be their survival. And yet within all these hardships, there is a quiet, profound beauty. The stars shine sharper in Mars' thin atmosphere. Sunsets glow blue, casting the landscape in colors unknown on Earth. The silence is complete, an emptiness that feels almost sacred. And each challenge met, each technology perfected, each breakthrough achieved brings Mars one step closer to transformation. Humanity learns discipline, patience, creativity. Mars becomes not just a world to conquer, but a world to understand. The harsh reality of Mars is not a deterrent. It is an invitation, a test that asks whether humanity is ready to evolve beyond comfort, beyond familiarity, beyond fear. If we can endure this world at its worst, we can earn the right to imagine it at its best. This is the beginning, the place where dreams meet the unyielding truth of an alien desert. Before terraforming, before oceans, before forests, before breathable skies, there is only survival. And survival is where every great transformation begins. Chapter 3. Terraforming Blueprint. The Engineering Marvels. Terraforming Mars begins not with science fiction fantasies, but with a daunting acknowledgement. We must reshape an entire planet, molecule by molecule, using technologies that stretch the limits of human imagination. This chapter opens with the earliest phase of that colossal undertaking, the blueprint, the master plan, the engineering doctrine that will drive humanity's attempt to warm a frozen world and rebuild a sky that vanished billions of years ago. The first objective is deceptively simple to express, yet unimaginably complex to execute. Warm the planet. Mars is too cold, its atmosphere too thin, its climate too fragile. If liquid water is to flow again, if plants, microbes, and eventually humans are to inhabit open environments, then the planet must be heated. Not by a few degrees, but by dozens. This is where engineers propose one of the boldest concepts in planetary history, placing immense orbital mirrors around Mars. These mirrors, spanning kilometers in width, would reflect concentrated sunlight onto the poles, delivering heat where it is needed most. The idea sounds elegant, silent, passive, reliant on physics rather than brute force, but constructing such mirrors in space requires manufacturing on a scale humanity has never attempted. Each mirror must withstand micrometeorite impacts, maintain precise alignment, and orbit reliably for decades, even centuries. Another approach is more direct: factories that release greenhouse gases into the thin Martian air. These CO factories would pump out powerful warming agents, built right on the surface and fed by the planet's own resources. They would slowly thicken the atmosphere, warming the planet from within. It is a strategy that mirrors what humanity has accidentally done on Earth, only this time intentionally, precisely, and with the full weight of global engineering behind it. These machines, humming day and night across the red sands, would be the first heartbeat of a world being reborn. Yet for all our methods of adding heat, Mars still guards one of the greatest prizes tightly beneath its skin: frozen carbon dioxide and water locked within the polar ice caps. If the caps could be melted carefully, strategically, they could release massive amounts of CO into the atmosphere, causing the air pressure to rise and the temperature to climb. With more CO in the sky, the greenhouse effect would strengthen, amplifying every warming effort. But melting an ice cap is no simple matter. Humans would be manipulating climate systems on a planetary level, requiring precise modeling, robust fail-safes, and an understanding of feedback loops that could either accelerate progress or push the planet toward unforeseen instability. Some proposals go even further, redirecting comets and asteroids rich in volatile compounds to crash into Mars. These impacts would deliver water, gases, and heat, instantly altering the atmosphere. It is a terrifying concept, one that blends astronomy, engineering, and raw cosmic force. One miscalculation, one altered trajectory, and the consequences could be catastrophic. Yet the idea remains on the table because terraforming does not shy away from scale. It demands it. Each of these engineering marvels represents one layer of an immense plan, a plan that spans centuries and requires unwavering human commitment. The blueprint is not just metal, energy, and technology. It is a generational promise that humanity will continue what it begins. Terraforming Mars is not a race. It is a relay. One age starts the work. Another advances it. Many more will see it through. This is the first step of the blueprint, the foundation upon which a new atmosphere, a new climate, and a new world will be built. Everything that follows depends on these grand, daunting engineering feats. Before humanity can breathe on Mars, the planet must first learn to hold an atmosphere again. At present, Mars' sky is a ghost, thin, fragile, incapable of trapping heat or shielding life. Terraforming requires more than adding air. It requires rebuilding the very processes that once made Mars warm and wet billions of years ago. This phase focuses on the controlled release of trapped gases, unlocking ancient reservoirs of carbon dioxide, water vapor, and other volatiles frozen beneath the surface. Deep beneath the Martian regolith lie pockets of CO, remnants of an era when the planet's air was thicker. Using a network of thermal drills and geothermal heaters, engineers will warm these reservoirs, allowing the gas to expand and seep upward. The process is slow, deliberate, and monitored with extraordinary caution. Each release alters pressure, wind patterns, and climate in subtle ways. But with time, a snowball effect begins. More atmosphere traps more heat, and more heat releases more atmosphere. Mars starts to breathe again, softly, almost imperceptibly at first. Alongside this natural release, a daring biological strategy emerges, the introduction of extremophile microbes. These organisms, engineered from Earth species or revived from ancient lineages, are capable of surviving under low pressure, intense radiation, and freezing temperatures. Their purpose is simple yet monumental: convert the raw materials of Mars into gases that support warming and future plant life. Some microbes convert CO into methane, others break down toxic perchlorates in the soil, gradually transforming Martian regolith into something that could one day sustain crops. These microorganisms would be the planet's first settlers, tiny pioneers, shaping a biosphere long before humans walk outside without a suit. But biology is only half the equation. Machines must work alongside microbes in a coordinated planetary ballet. Massive atmospheric processors devices, reminiscent of oversized air plants, would inhale raw Martian air and chemically transform it. They would output greenhouse gases, water vapor, and oxygen precursors. These processors replicate what volcanoes and oceans did naturally on early Earth. But on Mars, it is humanity that must build the machines to mimic nature's ancient rhythms. Still, none of this can succeed without addressing the core problem. Mars loses its atmosphere to space. Even if we create air, Mars cannot easily keep it. Without intervention, billions of tons of gases will slowly leak upward and vanish. This is where one of humanity's most ambitious ideas enters: the creation of an artificial magnetosphere. Engineers propose building a massive magnetic shield positioned at Mars' L1 Lagrange point, a location where gravity balances perfectly between the Sun and Mars. This shield, powered by nuclear fusion or next-generation solar arrays, could redirect solar wind around the planet, preventing atmospheric strip-off. If it works, Mars would once again have a protective bubble, allowing the atmosphere to accumulate rather than evaporate. In this phase of terraforming, everything begins to shift. The sky thickens slightly. The temperature nudges upward. Dust storms slowly become heavier, fueled by more substantial air. Subsurface ice pockets begin to melt. The planet's climate, dormant for ages, begins to stir. The transformation is invisible from day to day, but profound over decades. Mars transitions from a silent, brittle world to one that responds, however faintly, to human influence. This is the heart of the blueprint: machines, microbes, and magnetic engineering working together to awaken a planet that has slept for eons. The process is slow, complex, and unforgiving. But it is here, in this delicate interplay of biology and physics, that Mars begins its long journey from a frozen desert to a place where life can bloom. Terraforming a planet is not a single act, it is a sequence of monumental engineering transitions, each one building upon the last. And in this phase, humanity steps beyond warming the planet and releasing trapped gases. Now the objective expands towards something far more ambitious: shaping Mars' climate into a self-sustaining system. This is where engineering stops being merely mechanical and begins to border on ecological artistry. Once the atmosphere starts thickening, even slightly, a new set of tools becomes viable. Wind turbines, massive, towering structures, can take advantage of the increasingly dynamic Martian air. At first, the energy they produce will be modest. The wind, still thin, cannot push blades with Earth-like power. But as air pressure rises over decades, the turbines will evolve from experimental prototypes into major contributors to the planet's power grid, supplying the energy needed to run atmospheric processors, microbial bioreactors, and underground habitats. Mars slowly begins to shift from a world reliant solely on imported technology to one whose infrastructure grows from the changing environment itself. With the pressure rising and the temperature inching upward, the frozen water locked across Mars starts to respond. Subsurface ice melts into pockets and rivers trapped beneath the ground. Vast underground aquifers, repositories of ancient water, awaken. Engineers tunnel into these reservoirs, mapping their size, purity, and flow patterns. This water is the lifeblood of terraforming. It can feed hydroponic farms, support oxygen production systems, and gradually transform barren soil into usable substrate. More importantly, water vapor released into the atmosphere contributes further to the greenhouse effect, accelerating climate transformation. But water is more valuable than just a resource, it is a tool. Controlled flooding zones are established, where water is intentionally released to carve rivers, fill basins, and create the early foundations of lakes. These water bodies are not natural. They are guided landscapes, engineered blueprints of future ecosystems. Their purpose is to stabilize humidity, regulate temperature swings, and create microclimate, small patches of habitability, long before the planet is ready for wide-scale life. Then comes the most delicate stage, atmospheric composition engineering. With CO and methane accumulating, the warming effect grows stronger, but the planet's air is still lethal to humans. Oxygen must be produced not in small breathable pockets, but as a planet-wide atmospheric component. This requires algae, cyanobacteria, and engineered plant systems designed to survive low pressure, high radiation, and extreme temperatures. These organisms, deployed in shielded domes at first, eventually spread outward as the climate improves, feeding on CO and slowly exhaling oxygen. Over centuries, their combined output shifts Mars' air towards something more familiar. Not Earth-like, not yet, but closer to the threshold of supporting free-living ecosystems. Still, the transformation is not smooth. As the Martian climate begins to behave more dynamically, new problems emerge. Dust storms grow in complexity. Temperature differentials generate new wind patterns. Water vapor begins influencing weather in unpredictable ways. Terraforming teams must adapt continuously, adjusting planetary infrastructure mirrors, processors, reactors to stabilize the evolving climate. Terraforming is not a linear march. It is a constant negotiation with the planet learning to change. And through all this, Mars begins to show the first subtle hints of becoming something different. The sky shifts from pale orange to darker hues. The texture of the soil changes as microbes alter its chemistry. Frost patterns fade. Nighttime temperatures rise. For the first time in billions of years, Mars is not simply existing, it is responding. This is the middle stage of the blueprint, the moment where Mars ceases being a static wasteland and begins acting like a system, a climate. A world with moving parts, a world that is slowly coming back to life. As Mars' climate shifts from static to dynamic, humanity enters the most delicate and dangerous phase of terraforming, balancing the planet's new atmosphere, heat, and water cycles so that they reinforce each other instead of collapsing into chaos. This stage is often compared to tuning a vast, alien instrument. Every adjustment triggers ripple effects across the entire planetary system, and unlike Earth, where nature stabilizes itself through countless evolved feedback loops, Mars has none. Humanity must build those loops from scratch. The atmosphere at this point is no longer razor thin. It has thickened enough to generate real wind, real pressure gradients, and real storms, some helpful, some threatening. Engineers deploy a network of climate regulators across the planet, clusters of autonomous machines designed to monitor temperature, air density, humidity, and radiation. These machines communicate through a synchronized planetary grid, a digital nervous system that forms the backbone of the terraforming process. Through this network, humans can predict atmospheric changes weeks or months in advance, adjusting orbital mirrors, redirecting greenhouse outputs, or moderating microbial release rates when needed. One of the most surprising challenges comes from the increasing role of water. As more underground reservoirs melt and surface lakes begin to form, localized humidity rises. This creates the planet's first protocloud systems in millions of years thin, wispy formations drifting slowly across the sky. But these early clouds behave unpredictably. They can reflect sunlight, cooling regions unexpectedly. They can deposit frost where none is expected. They can evaporate suddenly, altering humidity by dramatic margins. Engineers must guide water distribution with meticulous precision, using controlled evaporation zones, artificial river systems, and even temporary weather shields to stabilize regions at risk of cooling too fast or warming too rapidly. At the same time, the soil, still toxic, still biologically empty, must be transformed into something capable of hosting life. This is where the next generation of engineered organisms plays a central role. Specially designed microbial colonies are introduced into the regolith in vast coordinated patterns. Some break down perchlorates, neutralizing the poisonous chemistry of Martian soil. Others secrete binding agents to prevent erosion as water begins shaping the terrain. Others still produce organic compounds that accumulate over decades, turning sterile dust into protosoil. This process is slow but transformative. It is the first step toward a Martian ground capable of nourishing plants. When the soil begins to change, humanity introduces the first experimental plant species, not outdoors, but inside massive, climate-controlled domes scattered across equatorial and midland. Inside these biodomes, engineered shrubs, mosses, and grasses grow under adjusted pressure and partial sunlight. Their purpose is not beauty, but biological function, to test what forms of life can survive in the shifting Martian environment. Over decades, these biodomes evolved from sealed systems into semi-open ones, gradually venting to the outside as conditions improve. Plants begin to interact with the early Martian atmosphere, exhaling oxygen, absorbing CO, and contributing to the planet's slow march toward habitability. This generation of plants teaches us something important. Terraforming is not about forcing Earth to exist elsewhere. It is about discovering what new version of life can flourish on Mars. What species can adapt to a different sky, weaker sunlight, cold nights, and thin air? What ecosystems can emerge in a world reborn? Mars will not become Earth. It will become something else, something distinctly Martian yet capable of sustaining life. By now, the transformation is undeniable. The landscape is changing color. White frost is rarer. Water flows in shallow channels during warm seasons. The air feels thicker, heavier. Machines and microbes work together like a planetary symphony. The blueprint is finally revealing its purpose, not a collection of isolated technologies, but a unified strategy guiding the birth of a new world. Humanity stands at the threshold of planetary engineering success. But the greatest challenge still lies ahead, ensuring that Mars' new atmosphere stays in place, and that the planet becomes truly self-sustaining. The quantum orchestra of reality. As we move deeper into the quantum labyrinth, the very nature of reality becomes increasingly difficult to hold on to. Every measurement twists the probability landscape. Every observation stiffens the fluidity of existence just long enough for us to name it, but only barely. And so we step into the next unfolding layer, where physics becomes poetry, and the universe reveals its structure not through objects, but through patterns, harmonies, and vibrations. Imagine standing in a vast hall so enormous its walls dissolve into darkness. There is no orchestra, no conductor, no instruments, and yet the air thrums with the unmistakable presence of a sound. Not a sound you hear with your ears, but a sound that exists as pure interaction, pure mathematical resonance. This is the quantum orchestra, the hidden structure that dictates how everything from atoms to galaxies organizes itself. To understand this orchestra, we must begin with the quantum fields, immaterial seas, each stretching infinitely across reality. Every particle you've ever known, electrons, photons, quarks, is not truly a thing. Instead, it is a ripple, a vibration, a disturbance in a field that spans the entire universe. You are not looking at matter, you are listening to a note. And here's the strangest part. All particles of the same type play the exact same note no matter where they are. Every electron vibrates identically. Every photon hums in the same universal pitch. This consistency is so perfect, so absolute, that if you replaced every electron in your body with electrons from across the galaxy, nothing about you would change. It's as if the universe uses a single blueprint, a single melody, replicated flawlessly across the fabric of space-time. But the harmony grows even stranger when we consider interference, how waves combine. When two quantum waves meet, they don't collide like particles. They overlap, they blend, they change each other. They create new patterns, new structures, new possibilities. Sometimes they amplify one another, rising into towering peaks of probability. Other times they cancel out, creating quiet voids of impossibility. This is not just math, this is the grammar of existence. Every event in the universe, the formation of a star, the bounce of a photon off your skin, even the electrical signals firing inside your brain, is governed by these waves interacting, weaving, interfering, restructuring the canvas of reality. And then there is coherence, the most delicate state in the entire universe. It is what allows particles separated by miles to behave as one. It is what holds quantum computers together. It is what causes lasers to be impossibly precise. Coherence is the perfect alignment of waves, like thousands of violins tuned to the exact same frequency. But coherence is fragile. The slightest interference from the outside world, a vibration, a stray photon, a shift in temperature, and the alignment collapses instantly. This is why the quantum world hides behind mystery. Interacting with it destroys it. In the quantum domain, to touch is to ruin. To see is to alter. To measure is to reshape. But in those fleeting moments where coherence survives, we glimpse something extraordinary, a world without separateness, without solidness, without boundaries. A world of pure relationship, a world where identity dissolves and only interaction matters. This is the quantum orchestra, not a collection of things, but a choreography of events. And as we move forward into the next layer of understanding, we begin to ask, if the universe is a symphony, who or what is listening? Chapter 4, The Hidden Dimensions Beneath Reality. As we enter Chapter 4, we step into the deepest realm of quantum speculation, the layers of reality that might exist beneath everything we know, everything we measure, everything we can even imagine. This is the domain where physics stretches to its limits, where mathematics becomes a lantern in the dark, and where the universe reveals whispers of dimensions beyond our senses. Let's begin in a place familiar yet deceptive. Three-dimensional space, length, width, height. Everything you see, touch, or recognize is built from these three axes. You move through them without effort, without thinking, as naturally as breathing. But what if these three dimensions are just the surface tension, the outer shell, of something infinitely more complex? To explore this idea, imagine standing in front of a blank sheet of paper. To a two-dimensional creature living on that paper, the world is flat. It knows only length and width. If you place your finger through the paper, the creature doesn't see your finger. It sees a circle. It sees only the flat projection of a much larger, more complex object. Now imagine that we are the two-dimensional creature, only instead of 2 dimensions, we live in 3. We see slices, not holes. We see shadows, not structures. We see cross-sections of a reality far richer than our perception allows. This is the foundation of higher dimensional physics. In modern theoretical physics, especially string theory and M-theory, the universe may contain 10, 11, or even 26 dimensions, most of which are hidden from us, curled tightly into microscopic shapes far smaller than atoms. You don't walk through them. You don't fall into them. Instead, they exist folded within every particle, every force, every quantum vibration. These extra dimensions could explain why gravity is so weak, why particles behave the way they do, and why the universe seems fine-tuned for complexity. But these dimensions are not just places. They are patterns of possibility. Picture each dimension as a direction reality can stretch, vibrate, or express itself. When a string, the most fundamental building block in string theory, vibrates, the shape of the hidden dimensions determines the tone of that vibration, and that tone becomes what we call a particle. Electrons, quarks, photons, all of them may simply be different musical notes played on the tiny, curled-up geometry of the universe. This means that the universe doesn't merely contain dimensions, it plays them. Every force you feel, every atom that forms your body, every beam of light traveling across the cosmos is shaped by these silent, invisible engines humming beneath existence. And although they are so small you will never see them, their influence is enormous. They sculpt reality from below. But this idea leads us to a profound question. If our reality is built on higher dimensions, why can't we perceive them? The answer may lie in how consciousness and biology evolved. Our senses did not evolve to detect the underlying structure of reality. They evolved to help us survive danger, find food, recognize faces, and navigate familiar environments. We don't need to see the quantum world or the dimensional framework beneath it. We aren't built for that. Our perception is not a window. It is a filter. And so the true architecture of the universe remains hidden behind that filter, glimpsed only through mathematics, through particle accelerators, through the subtle shivers of gravitational waves, or through the elegant symmetry of equations predicting what we cannot yet observe. As this chapter unfolds, we will go deeper into the hidden dimensional structure, not as a flat diagram, but as a living, breathing scaffold. We will explore brane-worlds, bulk space, Kaluzic line structures, and the possibility that our universe is only one layer in a vast cosmic stack. We will ask whether gravity leaks into higher dimensions, whether parallel universes are separated by imperceptible gaps, and whether reality itself is a hologram projected from a deeper dimensional field. This journey won't just change how you see the world, it will change what you believe the world is. Brane-worlds, the cosmic sheets beneath creation. Imagine for a moment that our entire universe, every galaxy, every star, every atom, is not floating freely in an infinite void, but is instead embedded on a membrane, a brain. Stretching across dimensions we cannot see, this brain forms the stage on which all of physics unfolds. Now imagine that there are countless other brains stacked like pages in a book, each with its own laws of physics, its own timelines, its own form of reality. They hover beside ours, separated by distances so small, so foreign to our perception, that they might as well be touching. This is the essence of brane-world theory, one of the boldest and most mind-bending concepts in modern theoretical physics. To picture it, think of a soap bubble floating through the air. The film of the bubble, thin, shimmering, delicate, represents a universe. Every particle of light, every quantum vibration, every bit of matter exists on that film. But the air around it, the volume outside the bubble, represents the higher dimensional bulk, a space larger, deeper, and stranger than anything contained inside the bubble itself. In brane-world physics, our universe is just the film, and the true reality is the bulk. What makes this idea revolutionary is that some forces of nature, like electromagnetism and the nuclear forces, are confined to our brain. They cannot escape. They're like ripples trapped on the surface of a pond. But gravity is different. Gravity may be the only force capable of leaking out of our brain, spreading into the higher dimensional bulk, and interacting with the other brains floating nearby. This could explain one of the oldest mysteries in physics, why gravity is so incredibly weak compared to the other forces. If gravity is not fully ours, if it drifts, bleeds, and pulls across dimensions, then the weakness we observe is simply the result of its power being diluted across realities. Now imagine two brains drifting close together, not touching but close enough that their gravity wells tug at each other, close enough that, in some models, particles might tunnel between them, close enough that a civilization living on one brain might sense strange anomalies, subtle distortions in gravity, mysterious missing energy. unexplained cosmic patterns, without ever realizing that the source lies just beyond the edge of their universe. The consequences are staggering. Entire universes could collide, merge or resonate with each other like vibrating sheets of cosmic fabric. Some theories even propose that the Big Bang itself was the result of two brains colliding in the bulk, a vast dimensional impact that released incomprehensible energy, igniting space and time as we know it. In this view, creation wasn't a singular explosion from nothing, but the rebound of titanic cosmic structures brushing against each other in the dark. But let's slow down and consider what this means for you, for consciousness observing its own universe. If brane-world physics is correct, then reality is far more layered than we ever imagined. Our universe has neighbors, hidden worlds, entire cosmic domains separated not by distance, but by dimensional orientation. They could be unimaginably close, yet totally inaccessible. Unless, of course, quantum tunneling, gravitational leakage, or advanced technology one day provides a bridge. Imagine civilizations evolving on sister brains, hearing faint whispers of gravitational waves from ours. Imagine them detecting anomalies they can't explain, not realizing that they're catching the faint echo of our universe vibrating beside theirs. Imagine the possibility that dreams of parallel realities, long preserved in myth and philosophy, were not metaphors at all, but distant intuitions of a truly multidimensional cosmos. In the next part of this chapter, we'll push further into the structure of the bulk itself, the invisible hyperspace where brains drift, and explore how higher dimensions might shape the physics we observe, the gravity we feel, and perhaps even the consciousness we experience. The bulk, the invisible ocean between universes. To understand the bulk, the higher dimensional expanse beyond our universe, imagine standing on a vast shoreline at night. The water before you stretches into darkness, silent and unknowable. You hear the waves, but you cannot see the depths. You sense the presence of something immense, but you cannot touch it. This is the relationship between our universe and the bulk. We sit on the shoreline, perceiving only the surface, unaware of the deep, multidimensional ocean unfolding beyond sight. The bulk is not empty. It is not void. It is a dimensional environment, a place where gravity spreads freely, where brains drift like colossal continents, where the rules of physics loosen and stretch. If our universe is a three-dimensional membrane, the bulk is a higher dimensional habitat, a space where distances shrink, expand, or curve in ways our minds were never built to visualize. To imagine even a small piece of the bulk, picture a sheet of paper floating in a room. The sheet represents our universe. The room represents the bulk. Now pick 2 points on the sheet separated by a long distance. From within the sheet, from within our universe, they are far apart. But from the vantage of the room, the bulk, they might be incredibly close. The sheet could fold, twist, or bend. The bulk shortcuts distances that seem insurmountable from our limited perspective. This is the foundation of extra-dimensional travel, not by moving faster, but by stepping outside the map. In the bulk, space is not constrained by the narrow geometry of our universe. Higher dimensional currents, geometric flows we can barely describe ripple through it, shaping how brains drift, how gravity bends, how cosmic structures evolve. Gravity, in fact, becomes our only messenger from the bulk. It is the single force able to seep between dimensions, carrying encoded hints of the bulk's structure. Every gravitational wave detected on Earth might be whispering secrets of higher dimensional tides, distortions, and distant brain interactions. Physicists have proposed that the bulk may have its own topology, its own shape, its own curvature, its own physics, independent of the universes it contains. It might possess dimensions curled tightly like microscopic spirals. It might contain open, smooth dimensions stretching infinitely. It might even host dimensional winds, pushing brains slowly across cosmic timescales like continents drifting on a higher dimensional tectonic sea. Some theories suggest that dark matter, the invisible mass shaping galaxies, may actually be matter on a neighboring brane. its gravitational influence bleeding into our universe through the bulk. Imagine stars and planets forming on a parallel brane, unseen, untouched, yet tugging subtly on our cosmos. We feel their gravity, but not their light. We sense their presence, but not their substance. This would mean that billions of galaxies we cannot see might exist just beyond our dimensional horizon, part of a cosmological ecosystem far richer than we ever imagined. The bulk could also be the birthplace of universes. Some models describe regions where energy condenses into new branes, forming infant universes that grow, expand, and evolve. Others imagine collisions between branes as cosmic events so powerful they generate big banger-like expansions. In this view, universes are not rare. They are blooming, colliding, drifting, and dissolving within the vast higher-dimensional medium of the bulk. Even consciousness might have roots in this multi-dimensional architecture. If the brain interfaces with quantum processes, as some interpretations suggest, then it may interact with geometry shaped by the bulk itself, not by perceiving it directly, but by resonating with the deeper patterns of reality shaped by higher dimensions. The idea that awareness might be influenced by hidden dimensions is speculative, but intriguing. Perhaps the limits we experience are not absolute, but simply the limits of our three-dimensional vessel. In the next part of this chapter, we will explore the most radical possibility of all, that our universe, this brane, is not fundamental, that it is a projection, a hologram cast from deeper, higher dimensional laws, a universe written on the boundary of something larger, the holographic universe, reality written on a cosmic screen. Imagine standing before a vast, seamless wall, smooth, black, and infinitely wide. You reach out, place your hand on its surface, and feel nothing. No depth, no structure, just a boundary. Now imagine that everything you have ever known, every star, every particle, every moment in time is written on that boundary. Not inside it, not behind it, on it. Like a hologram. This is the holographic principle, the staggering idea that our entire universe may be a three-dimensional projection emerging from a two-dimensional surface embedded in a higher dimensional space. To grasp this, picture a hologram on a credit card. At a glance, it displays a three-dimensional image, shapes with depth, shadows, angles, yet the information that creates this illusion is encoded on a flat surface. Your eyes perceive volume where none exists. The universe, some physicists propose, might work the same way. What we experience as space, the vast three-dimensional arena of galaxies and nebulae, may be a kind of cosmic mirage, a reconstructed reality projected from deeper information inscribed on a distant boundary of space. This isn't poetic metaphor. It emerges mathematically from black hole physics. When a star collapses into a black hole, all the information about the matter that formed it becomes somehow stored on the event horizon, the two-dimensional surface surrounding it, not inside the black hole, but on its surface. This discovery stunned physicists because it implied that the fundamental storage capacity of space-time is measured not in volume, but in area. In other words, the universe behaves as though its deepest truths live not at the center, but at the edge. If the cosmos truly follows holographic principles, then every particle you see, every quark, every photon, every wave of space itself, arises from encoded information on a distant cosmic boundary, perhaps the outer edge of the universe, perhaps a brane in the bulk, perhaps a deeper dimensional sheet where reality is inscribed like a vast cosmic ledger. What we perceive as here might be the unfolding of information from there. This idea challenges our intuition. We walk through a room and feel its volume. We breathe air that fills our lungs. We see planets suspended in space. Everything suggests three-dimensional existence. Yet the mathematics of holography tell a different story. Depth may be an emergent phenomenon, a beautiful illusion woven from patterns we can't directly sense. In this model, consciousness itself may not be escaping the hologram. It may be part of its fabric. The self, the mind, the internal world of thoughts and experience could all arise from the way information unfolds through the dimensions available to us, not as separate from the cosmos, but as an expression of it. Your awareness is not outside the hologram. It is a living pattern within it. And here is where the idea becomes even more breathtaking. If reality is holographic, then what we call physical laws, gravity, quantum mechanics, electromagnetism, may simply be byproducts of deeper informational rules operating on the boundary. Einstein's space-time curvature, a holographic pattern. Quantum fields, holographic vibrations. The expansion of the universe, a shifting boundary condition. In this view, the fabric of reality becomes something like a cosmic data field, a place where information gives rise to space, energy, matter, and time. And the bulk, the higher dimensional expanse we explored earlier, becomes the true scaffolding on which the hologram is projected. Our universe would be a kind of shimmering image hanging within the bulk like a luminous veil. What does this mean for existence? It means that the universe is far stranger, more layered, and more interconnected than our senses reveal. It means that what you see as the world might be a shadow cast by deeper laws. And it means that the boundary of reality, the place where the hologram is written, might hold answers to questions we haven't yet learned to ask. The multidimensional architecture of reality. As we reach the final part of this chapter, we step into the deepest synthesis of everything we've explored, the possibility that the universe is not simply a place, or a space, or even a brain, but a carefully layered construction woven from dimensions, fields, and informational boundaries. A cosmic architecture, a multidimensional design. Imagine for a moment floating above a vast illuminated city at night. At street level, the world is chaotic, cars, lights, movement, noise. But from above, patterns emerge, roads, clusters, networks, hidden structure beneath the complexity. Now imagine lifting even higher until the city becomes a quiet grid of lights, and then higher still until even the grid dissolves into a pattern of luminous threads connecting an entire continent. The closer you are, the more complicated things appear. The farther you rise, the more the underlying geometry reveals itself. Reality may work the same way. Quantum mechanics, the chaotic, jittering dance of particles, is the street level. Brain theory, vast cosmic sheets drifting through the bulk, is the level above that. The holographic principle, the idea that the universe is written on a distant surface, is another level higher. And beyond all of these, there may be a single, unifying structure from which all these layers arise. Think of it as a cosmic blueprint, a dimensional architecture composed of brains, the membranes on which universes are painted, the bulk, the higher dimensional ocean in which brains float, holographic boundaries, the 2D informational surfaces encoding 3D reality, quantum fields, the vibrating patterns generating matter and force, space-time geometry, the shape carved by energy and mass, deep information, the ultimate language from which everything emerges. Each layer shapes the one beneath it. Each level is a translation of deeper rules into observable phenomena. Every atom, every star, every moment of your life is built from this ladder of realities. Now imagine the bulk, a higher dimensional realm where brains drift like luminous tapestries. On these brains, universes unfold, expand, cool, and form galaxies. Each brain, in turn, may be a hologram projected from an even deeper informational surface. And beneath that surface, deeper still, lies a lattice of mathematical structure, a kind of fundamental geometry where the rules of physics originate. In this picture, the universe becomes a masterpiece of organization. Not random, not accidental, but structured at every level by relationships between dimensions. The motion of a planet, the spin of an electron, the formation of a galaxy, all of it arises from tensions, vibrations, and flows in dimensions we cannot see. And if consciousness is woven into this architecture, then awareness itself might be an emergent property of the universe's multidimensional design, the cosmos observing its own structure through biological vessels. This final layer, the unity of dimensions, suggests that reality may not be a solitary universe, but a vast multiverse of brains, each flowering from deeper information, each a different expression of the same underlying architecture. Some may have different physics, some may be empty, some may teem with complexity, and some may lie so close to ours that gravity bleeds through their boundaries, whispering their presence. The true nature of reality, then, may be neither matter nor energy, neither space nor time, but the relationships between dimensions, an intricate, elegant network from which everything else emerges. In this multidimensional architecture, you are not merely a passenger in the universe. You are a pattern woven into its fabric, a ripple on the brain, a resonance in the field, a conscious moment of the cosmos knowing itself. This is a quick reminder for you to like, share, and subscribe to our channel. Thank you. Chapter 5, Part 1. The Long Game. Humanity's Cosmic Responsibility. As we begin Chapter 5, we shift from observation to action, from understanding the cosmos to considering humanity's role within it. All the knowledge of planets, brains, quantum fields, and hidden dimensions leads to one unavoidable truth. We are no longer merely passengers in the universe. We are becoming active participants, capable of shaping worlds, altering climates, and eventually constructing entire ecosystems beyond Earth. And with that power comes a responsibility unlike any humanity has ever faced. Consider the scale of the task. Mars, a frozen, desolate planet, waits silently for our influence. Its thin atmosphere, harsh radiation, and toxic soil are not obstacles to be ignored. They are immutable realities demanding ingenuity, patience, and precision. Terraforming Mars is not a weekend project. It is a generational endeavor spanning centuries, perhaps millennia. Every decision made by our first colonists will ripple forward, shaping the conditions that their children and their grandchildren will inherit. This is a commitment of time and resources that stretches far beyond the typical human lifespan. Beyond politics, beyond nations, it is a project that requires global cooperation and a willingness to think in terms of centuries, not decades. And yet the challenge is as ethical as it is technical. Do we have the right to alter a world? To introduce Earth life into a planet that has evolved for billions of years under its own conditions? Some argue that Mars is a pristine environment, a natural laboratory of planetary evolution that should remain untouched. Others see the opportunity to ensure humanity's survival, to create a second home that guarantees the continuation of our species. The debate is profound because it forces us to confront questions about stewardship, responsibility, and the balance between exploration and preservation. The technical hurdles themselves are staggering. Creating a breathable atmosphere requires machinery that can operate autonomously for decades, even centuries. Microbial colonization must be carefully managed to avoid runaway ecosystems. Water must be released gradually to prevent catastrophic flooding, while temperatures must be increased incrementally to avoid destabilizing the nascent climate. And above it all looms the question of radiation protection until a planetary magnetic shield is developed. Every human settlement will remain vulnerable to cosmic and solar radiation. The task is a delicate dance between nature's laws and human engineering, where one misstep could set the entire project back decades. But even amid these challenges, the potential rewards are breathtaking. A terraformed Mars represents not just a backup plan for humanity, but a laboratory for learning how life, ecosystems, and civilizations interact with planets on a scale never attempted before. Every discovery, every breakthrough on Mars will inform future projects across the solar system, from Europa's oceans to Titan's methane seas. Mars is not the end goal. It is the first step in humanity's expansion into the cosmos. To terraform one planet is to acquire the knowledge, tools, and experience needed to transform many more. And beyond the technical and ethical considerations lies a deeper truth, the psychological and cultural transformation required. Life on Mars will demand new ways of thinking, new social structures, and new philosophies. Communities will need to value cooperation over competition, foresight over short-term gain, and global responsibility over national pride. Generational commitment is not just about survival. It is about cultivating a civilization capable of patience, adaptability, and wisdom at an unprecedented scale. Our descendants will inherit the consequences of choices we make today, a legacy that is both daunting and inspiring. In this first part of Chapter 5, we begin to grasp the enormity of humanity's long game. Terraforming is not simply a scientific experiment. It is a statement about our species' intentions, capabilities, and values. It is about embracing responsibility on a planetary scale. And it is about envisioning a future where human civilization extends beyond Earth, interacting responsibly with other worlds while preserving the delicate balance between innovation and respect for natural processes. This is only the beginning of the journey. In the next part, we will explore the technologies, strategies, and visionaries who are already laying the groundwork for Mars. Transformation, the pioneers of a project that could reshape not only a planet, but the destiny of our species. Pioneers, technologies, and the Martian frontier. As we continue our journey into the long game of humanity's cosmic responsibility, we now turn to the pioneers, the scientists, engineers, visionaries, and dreamers laying the first stones of a future Martian civilization. Their work is not about fantasy. It is about confronting one of the most extreme environments in the solar system and finding ways to survive, adapt, and ultimately transform it. The Martian frontier is a place of extremes, temperatures dropping to -125 degrees Celsius at night, dust storms that can engulf entire hemispheres, and an atmosphere too thin to support unprotected human life. Every step on this surface is a confrontation with reality at its rawest. The first technologies under development aim to provide safe habitats, sustainable energy, and reliable life support. Modular shelters with radiation shielding, powered by nuclear or solar arrays, form the initial footholds. These are not merely homes. They are laboratories, factories, and nerve centers for future expansion. Every material used, every system implemented is a proof of concept for larger-scale terraforming. Recycling air, water, and waste becomes not just a necessity, but an art form, because the planet will not provide resources in abundance, at least not initially. Power generation is critical. Solar panels provide energy during daylight hours, but dust storms can render them almost useless. Nuclear reactors, small and scalable, offer stability, but must be designed to operate remotely, autonomously, and safely under harsh conditions. Meanwhile, robotic assistants lay the groundwork for construction, mining, and maintenance. These autonomous machines are the unsung pioneers, working tirelessly to prepare Mars for human hands before we even step outside without a suit. Water is the lifeblood of this effort. Subsurface ice, polar ice caps, and hydrated minerals must be located, extracted, and managed carefully. Techniques range from heating soil to release water vapor, to drilling deep reservoirs and pumping it to the surface. The ultimate goal is not simply survival, it is the creation of liquid water systems capable of supporting microbial life, and eventually plants, algae, and larger ecosystems. Each drop of water represents not only sustenance, but progress toward a planet slowly awakening. Communication and navigation technologies are equally vital. Mars is over 140 million miles from Earth. Signals take minutes to cross the void. Real-time remote control is impossible. Instead, intelligent systems, machine learning, and predictive models coordinate the vast infrastructure of robotic explorers, life support systems, and environmental processors. Every success, every failure is observed from afar and feeds back into the growing knowledge base that will guide future generations. And yet, for all this technological sophistication, there is still a human element. The first settlers will need more than skill. They will require psychological resilience, social cohesion, and an ability to make ethical decisions in isolation. Mars will test patience, judgment, and morality. Generational thinking is not an abstract concept here. It is literal. Decisions made today will influence conditions centuries into the future, determining whether a self-sustaining society can emerge or whether Mars remains a harsh, unyielding wasteland. This is also where ethical and philosophical considerations resurface. Introducing life to Mars, even engineered microbes or hardy plants, raises profound questions. Are we preserving the planet or imposing our vision upon it? Is Mars a laboratory for survival, a second Earth, or a unique world deserving of protection in its own right? The pioneers must navigate not only physical and technological hazards, but the moral and existential implications of shaping an entire planet. In this stage, we begin to see the long game take form, small, deliberate steps leading to larger transformations. The combination of human ingenuity, robotic labor, and technological precision begins to generate a fragile equilibrium, a foothold on the surface of a world that once seemed utterly inhospitable. And within this balance lies the seed of Mars's ultimate potential, a living, breathing, human-inhabited planet. In the next part, we will explore the ecological and atmospheric transformations required to take Mars from a fragile outpost to a true, habitable world, the step that moves humanity from survival to full-scale terraforming. As we step back from the vast scope of terraforming, planetary engineering, and multi-dimensional exploration, one truth becomes clear. The story of humanity is no longer confined to a single world. From Earth to Mars, from quantum fields to hidden dimensions, our journey is a journey of discovery, responsibility, and transformation. What began as curiosity has evolved into capability. What began as imagination has become planning, and what began as survival has become a vision for our species' future among the stars. Mars, once a desolate, silent world, now emerges as a canvas of possibility. Its thin atmosphere, frozen soils, and red dust are slowly giving way to flowing water, breathable air, and life, engineered and nurtured by human hands. The first outposts, small and fragile, become the seed of civilizations capable of spanning centuries, guided by cooperation, foresight, and ethical responsibility. Humanity learns to live in harmony with the forces of a planet, balancing ambition with restraint, and creating an ecosystem that was once unthinkable. Beyond Mars, the lessons extend to the stars. The technologies, knowledge, and vision gained here are the foundation for a future where humanity is not bound to a single world, but is truly a multi-planetary species. Terraforming teaches us patience and engineering, but it also teaches us humility and stewardship. It teaches us that shaping a world requires not just power, but wisdom, cooperation, and care for the life that might flourish there. Yet the journey does not end with physical planets. As we've explored the quantum world, higher dimensions, and holographic universes, we begin to see that reality itself is far stranger, more layered, and more interconnected than we ever imagined. Our place in the cosmos is not simply as observers, but as participants. The universe is a vast symphony of energy, information, and potential, and humanity has begun to play a conscious note in that grand orchestra. The dream of stepping onto a world with breathable air, rivers, plants, and cities under a blue sky is no longer science fiction. It is a vision within our reach, a horizon that stretches across time and space, demanding the best of our imagination, our courage, and our commitment. The Red Planet, once lifeless, may soon host the first chapters of a new civilization, and beyond it, countless other worlds wait, offering challenges and opportunities that will define humanity for millennia. As our gaze turns back to Earth, we see a planet rich with life, beauty, and history. But we also see a species capable of reaching beyond its cradle, a species poised to explore, create, and thrive in the vastness of space. Mars is the first chapter in a story that spans galaxies, dimensions, and the very fabric of reality itself. This is not the end. It is the beginning of a future in which humanity dares to dream, dares to act, and dares to become a cosmic civilization. The red planet is waiting. The universe is waiting, and the symphony of creation, life, and possibility plays on, inviting us to join its eternal chorus.